Welcome to the biology video on going through the practice problems for the periodic table. As you go through this video, make sure you've done the worksheet first, because if you just watch the video and you haven't done the worksheet, you're not going to know what you don't know. And knowing what you don't know is more important than memorizing the things I tell you. So it's very important when we do a practice worksheet like this that you go through and try it first so you can figure out what you do know already and don't need to focus so much on, and what you don't know yet and need to focus on. So as we look at this worksheet, we'll go through and we'll compare it to the periodic table, and we'll see how we can answer these problems. Now, one of the things the periodic table tells us is how we can use it to determine the structure of atoms. So let's say in this first problem, it says use the periodic table. We're going to identify the elements below. In the nucleus, the white circles are the protons, the filled in circles are the neutrons. So when you look at the periodic table over here, the number that's in this periodic table box is the atomic number. Now when you look in your book, it'll also talk about the mass number, and we'll look at the mass number too here in a minute. But what we're looking at right now is the atomic number, because that's what defines an element. Elements can have similar mass numbers and be different elements, but their atomic number defines them. So hydrogen always has an atomic number of 1. That means it has 1 proton. Helium 2, and so on and so forth. So when we look at this atomic number, that tells us the number of protons. So if we look at the first one on our worksheet here, so we look at letter A. Letter A has 1, we looked at the open circles, 1, 2, 3, 4, 5, 6 protons. Protons, remember, are positive. They're always going to match our negatives in a neutral atom unless it's an ion, and when we're doing something like this, it'll always be neutral. So 1, 2, 3, 4, 5, 6 electrons also. And when we look at the periodic table, the one that has 6 is carbon. Now, when in this particular periodic table, we have the mass number here, and we'll talk about the mass number here in a minute. But on a normal periodic table in your book, you'll see the mass number on here too. Remember that the atomic number is always your smallest one. The mass number will be bigger, and the mass number is usually going to be a decimal because of the isotopes. And again, we'll talk about isotopes here in a little bit. So back to the worksheet here. So A has 6 protons, so it is carbon. Let me decrease the size on that a little bit, a little hard to read. Okay, next we have, this one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 protons. 10 protons balanced by 10 neutrons. Or I'm sorry, by 10 electrons to make it balance. Now something to see in this one is that it talks about the Octet Rule in your textbook. The Octet Rule applies to every shell above the second, or I'm sorry, starting with the second above the first. The first shell can only hold 2 electrons. After that, any remaining electrons are put into the second shell. Since this had 10 protons, it will have 10 electrons, 2 in the first shell. The second shell is full with 8. So 1, 2, 3, 4, 5, 6, 7, 8. That's a total of 10. 10 protons, 10 electrons, which over here 10 tells us that, if we click on 10 here, that is neon. So this one is neon. Okay, next we have 1, 2, 3, 4, 5 protons, 5 electrons. 5 would be, and I'm not going to click back and forth each time, you can look at your periodic table. B is boron. Now something about boron, I will have to click on this one after all, is when we look at boron, boron has a mass of 10.811. Now remember from your book that the mass number is the number of protons plus the number of neutrons in the nucleus of an atom. Electrons are so small that their mass is fairly insignificant. Now we can't have a decimal of neutrons, so what we do is we round this to the nearest whole number, which would be 11. The reason for that is because of the isotopes, and in this periodic table it'll tell you that the most common isotope, 80% of all atoms have a mass number of 11 with 5 protons and 6 neutrons. Now some of them will have 5 and 5, which means sometimes it's 10, and that's why it's a decimal. Most of the time it's 11, sometimes it's 10. When you average it out, it's decimal. So when we're dealing with neutrons, we always take it to the nearest whole number. So 1, 2, 3, 4, 5, 6 neutrons. We don't use neutrons to define the element, we use protons. Okay, next one. 1, 2, 3, 4, 5, 6, 7, 8. We have 8 protons. Just to double check, we have 1, 2, 3, 4, 5, 6, so 8 electrons. 8 over here on the periodic table is oxygen. So this is a representation of oxygen. Here, this little bitty one, only that shell fills up with 2. So 2 protons, 2 neutrons, 2 electrons. 2 is helium. 1 is 1 proton, 1 electron, hydrogen. Hydrogen doesn't usually have a neutron, so it has a mass number very close to 1. But you can see that it does have a neutron sometimes, but very, very rarely, because its mass number is very, very close to 1. Next we have 1, 2, 3 protons, 3 electrons. That would be lithium, because 3 protons right here on the periodic table is lithium. Lithium has normally 4 neutrons, so its mass number is very close to 7, and you can see that on your periodic table. Next, 1, 2, 3, 4, 5, 6, 7. Double check here. 1, 2, 3, 4, 5, 6, 7. Yep, 7 protons, 7 neutrons. The atomic number 7 goes with nitrogen. And then 1, 2, 3, 4 protons, 4 electrons. Number 4 is beryllium. And again, that has 5 neutrons. So don't use your neutrons to determine your element, because neutrons can vary based on the isotopes. Protons will not vary. If this atom had 5 protons, it would not be beryllium, it would be boron, because protons determine the atom. Okay, let's move on. Let me get rid of that writing. Let's move on here and look at some math. Alright, in a normal periodic table, like I said, you're going to see 2 numbers. You're going to see the smaller number, which is your atomic number, and you'll see the larger number, which is your mass number. Now, the mass number of oxygen, 15.999, we cannot have a decimal number of neutrons. That decimal is because of the fact that sometimes it's 16, very rarely it's 15, which would mean we'd have 7 neutrons, and that brings it down a little bit. When we look at the atomic number, as we said, tells us protons. It also tells us electrons, but only if the atom is neutral and is not an ion. If it has a positive or negative charge, then the electrons will vary. Atomic mass always equals the protons. Protons are the key, plus neutrons. We'll see how to figure that out here. Alright. O, we fill in the name, oxygen, and you won't have to memorize these. I mean, you'll get to know some of them, but you won't have to memorize them because you will always have your periodic table with you. So it has an atomic number. Atomic number is the smallest one of 8. Atomic mass, 15.999. When you're doing atomic mass, round it to the nearest whole number. So 16. Number of protons always equals your atomic number. Number of electrons, I'll skip down here, always balances your atomic number. Number of neutrons is mass minus the number of protons, so that in this case is also 8. Protons plus neutrons equals mass, right here. Okay, zinc is Zn. Again, you don't have to memorize these, you can look on the periodic table. Atomic number of 30, atomic mass of 65. So 30 protons balance 30 electrons. To figure out neutrons, we take 65 minus 30, which is 35 neutrons. Remember, your number of protons plus your numbers of neutrons equals your mass. Lithium is number 3, has an atomic number of 3, an atomic mass of 7, and a number of protons of 3, electrons 3, 7 minus 3 gives you 4 neutrons. Silicon is Si. Don't get it confused with sulfur, which is S. Atomic number of 14. atomic mass of 28, number of protons 14, electrons 14, neutrons 28 minus 14 is also 14. And that continues on for the rest of these. Boron, atomic mass 11. Remember, we're going to take it to the nearest whole number. 5, 5, 6, because 11 minus 5. Bromine has an atomic number of 35, atomic mass of 80, number of protons 35, number of electrons 35, 80 minus 35, I don't want to mess that one up doing it in my head because I'm 80 minus 35, 45. Okay. For the rest of them, I'm not going to do the rest of this sheet. You can do the rest of them if you go through them and check. Actually, go ahead and do them. Let me pause the video. We'll see if this works here. I haven't used this video program very much. We'll pause it. I'll fill in the rest of them and then you can check them. Just a sec. Okay, I filled those in. Go ahead and check those. I'm not going to leave it up there for very long. Just pause the video here at this spot while you check it. I did go kind of fast, so let me know if you find any errors. What we're doing this for in biology is because these elements are going to go on and be combined into molecules, and then the molecules are the building blocks for cells and organs and tissues. And sometimes there's not a lack of knowledge about it, but people don't really think about that whole process and realize, you know, hey, these elements are what are actually building everything. So we have to look at the building blocks, because if we don't have a strong knowledge of the bricks, we can't build the wall. So knowing the elements is important in that. Okay, let me clear this. And again, if you don't have them all checked, then just pause the video and check them. And then we will go on and look at the next part. In the next chapter, we're going to start looking at molecules. So we'll kind of get a idea of those here. Again, you're going to use your periodic table, because I don't expect you to memorize these elements. You will, learn some of them, but you don't have to memorize them. Okay, when we look at molecules, it's important to be able to read the formula. Some of the formulas are fairly simple, and they deal with bonding, because an atom wants to have a stable number of electrons in its valence shell in order to have a good stable bond. So the numbers, and we won't worry too much about how we get these numbers, that's chemistry. I mean, you'll learn that when you take chemistry. But we need to be able to read them and use them intelligently when we are doing molecules and going on and looking at cells and membranes. All right, H2. The element we're dealing with is hydrogen. When we have a subscript, that tells us that we have 2 hydrogens in that molecule. Same thing for the next one, oxygen, and there are 3 of them in a molecule. Now when we combine elements in a molecule, we take the abbreviations. Let's do that first. We have hydrogen and oxygen in this molecule, and the subscript only refers to the letter that comes in front of it, the symbol that comes in front of it. So there are 2 hydrogens, but there's no number after oxygen, which means there's only 1 of them. So this molecule of water has 2 hydrogens, dihydrogen, and an oxygen for water. This molecule, ammonia, is a nitrogen. There's no number after it. This number does not distribute to nitrogen. It stays with its element. So there's only 1 nitrogen. Hydrogen has 3. Carbon dioxide, we have 1 carbon. There's no number after it, so it's a 1. And oxygen, 2. Dioxide means 2. Now the reason I put this one on here, sodium chloride, we're going to see this a lot, is that one of my pet peeves with chloride is the way that people write it because they haven't had chemistry, which isn't your fault if you haven't had chemistry, and I'm not saying that an individual will do this, but I see this a substantial amount of time, and that is that chloride here, element number 17, is an uppercase C and a lowercase l. It is not an I. I is iodine. And that's a common mistake that people will write it like this, and that is not what it is. Hydrochloric acid is HCl. Capital H, capital C, lowercase l. So in this case we have sodium chloride. Oops, I didn't mean to do that. I'll write it over here. Sodium from natrium, which is the Na, and chlorine. So we have 1 sodium, 1 chlorine. This is glucose, C6H12O6. We have carbon, hydrogen, and oxygen. We have 6 carbons, 12 hydrogens, and 6 oxygens. Now down here, I threw this one on here. This is methane. We have a carbon, and we have hydrogens. In the molecule, there's 1 carbon and 4 hydrogens. However, when you put a 2 in front of it, you multiply everything by that. So in 2 molecules of methane, there are 2 carbons, and 8 hydrogens. So sometimes you'll see a number in front. That's the only way to distribute across both. Again, you don't have to know the details of bonding or anything like that at this level. As far as how many go with what, you'll get that when you take chemistry. But we do have to have some familiarity with the periodic table in order to understand how we build our molecules, how those molecules are used to build organelles, how organelles are used to build cells, and how cells are used to build living things.